Hello, everyone, and welcome to this second session of our online training, Intellectual Property for Deep Tech Businesses. We hope, of course, many of you already participated in our first session last week, focusing on IP strategy aspects. Today, we are going to shine a light on IP management. For those of you who haven't joined us last week, my name is Stephanie Weber, and I'm a member of the European Intellectual Property Help Desk, an IP service initiative provided by the European Commission. We're glad to support this training, which is organized by the European Patent Academy of the European Patent Office and the European Innovation Council and SMEs Executive Agency. And personally, I am particularly delighted to be once again your host this afternoon and navigate us through today's training agenda. Before we dive into today's topic, let's do a quick recap of some key takeaways from last week's so-called IP Strategy Day. So one of the key messages all of our speakers tried to convey to you last week was that intellectual property is far more than a legal requirement. It's essentially a strategic business asset that opens up options and opportunities for you, supporting and helping you reach your business goals. IP is also more than patents. We have to think beyond patents and consider additional intellectual property rights such as trademarks, designs, trademarks, or trade secrets, sorry. And so oftentimes, as we heard last week, a smart combination of these different IP rights actually helps you unleash the full power of your IP strategy. That said, your IP strategy should be aligned to your business strategy. That also means that there cannot be a one-size-fits-all solution. It has to be individualized. It has to be tailored to your specific business needs. And also, your IP strategy won't be static. It will need to evolve, and you potentially need to adjust it according to new developments in your business, but also in the market that you're operating in. However, as we heard so nicely last week, it's also not a strategy that you change like you do change your underwear, hopefully. It's meant to reflect a long-term perspective, providing and defining the scope of your business actions. And lastly, innovation management is a team sport. You won't be able to do it alone. You'll need several players bringing in different expertise, know-how, background, and you have to sort of join them. And you also have to be able to listen to and speak the language of those different people to transmit or convey the value of IP and to craft an IP strategy that takes everyone on board. So today, based on these considerations, we'll zoom in on IP management, aiming to give you, once again, very practical insights and knowledge into the major pillars of IP management and how you can improve the IP creation pipeline. We'll also look at tools and mechanisms to identify the winning technologies, the so-called champions in your technology portfolio, and learn more about how to protect the obvious and perhaps not so obvious inventions in that portfolio. And plus, we will address freedom to operate assessment and tell you how you can tackle that, also introducing tools and support mechanisms that can help you do that. As in last week's session, we're going to record, you'll be able to ask questions as we go along. And as last time, please use the Q&A function for that. We will either address those questions in written on the fly as we go along, or we select and filter some of them and relay them to the plenum in the two envisaged Q&A sessions. One will be right after the first series of talks, and the second Q&A will be after the Freedom to Operate assessment talk. Also be reminded that we're recording the session and you will receive the slides of the presentations afterwards. We decided to provide you with access to the slides also from last week's session in one go. So you receive an email following up to this training, providing you with more information of how to access the presentations and then also the recordings later on. And of course, also as last time, much appreciated. We would like to hear from you and would be glad if you could fill in a short survey that will launch right after the end of this training session. And with that, I think we're ready to go. And I'm pleased to pass on the floor to Thomas Bereuter. Those of you who joined us last week know Thomas already. Thomas is Innovation Networks Manager with the PatLab Centers at the European Patent Academy. He has a wealth of experiences to share from more than 25 years supporting high-tech businesses, spinning out, founding businesses himself. So Thomas, very glad to have you back on this virtual stage, and please go on, and the floor is yours.
Definitely, thank you very much for that absolutely excellent summary of our IP strategy day. I think that is a very good start. I have prepared some slides that I'm happy to share with you. Let's see if we can make that work. Oops. So you should now see the slides. I will walk you through the core pillars of efficient IP management, like Stephanie announced, place them into a broader context, and illustrate them with some concrete examples, particularly around IP creation. Before we dive in, let's briefly reconnect with some key points we have already heard last time. You might remember one of the key slides that I presented last time. And hopefully you remember the analogy I used. If IP strategy helps you win the war, then IP management is what helps you win the many battles along the way. I focused a lot on making a difference between IP strategy and IP management to be precise with the wording, so to have a better learning. So to do this, proper IP management, IP professionals often work like engineers using a magnifying glass approach to detect potential hurdles early on and secure the right intellectual property in an efficient and targeted manner. Just to repeat, there are three key features that define strong IP management. It ensures legal protection and compliance. It relies on standardized processes and tools, and it is routine-based, designed for consistent, repeatable execution. Effective IP management rests on four main pillars. It's about IP creation, evaluation, protection, and exploitation. This may seem like a linear process, and that makes it easy to remember, so that's an advantage. But be aware that in reality, these steps must be handled in an orchestrated way. At the end of the day, each decision will be informed by the ones that follow. So you look ahead, what are the next steps ahead? It's a little bit like playing chess, where you already know what are the next moves. Let's look into a practical scenario. And I think that's quite close to the EIC environment. Out of 3 submitted proposals, one might become a funded R&D project. In high-tech or deep-tech domains, it is common to start with over 1,000 conceptual ideas or design variants to solve a specific technical or commercial challenge. Through iterative design, simulation, and prototyping, this broad funnel narrows down to around 10 technical feasible and commercially promising solutions. Due to limited resources, maybe only 3 to 5 of these may be advanced to higher technology readiness levels. So that's quite a selection process. And this process requires a structured approach, usually considering technical performance, legal viability, market potential, the financial aspects, and strategic fit. So 5 areas you need to take care of. You will hear more about that later from Johannes. As then a clearer product or service vision emerges, IP becomes central. At this stage, the latest, patentability and freedom to operate analysis are conducted. Out of the advanced technologies, only 1 or 2 may yield strong and enforceable IP positions, greatly influencing further investment or commercialization decisions. This kind of structured innovation process is also known as a stage gate process, where each phase ends with a decision gate, and that means go, kill, or prioritize. This is illustrated in the next slide. It's not meant that we go into the nitty-gritty details of that slide, as there is a great open access article that we have prepared for you. It's available online and gives you a clear overview of the stage gate process and its role in a structured innovation process. It's on epo.org/SME, but on the slide that we will share with you, I added more precise links, saving you some clicks. In the upcoming sessions today, we will dive deeper into key aspects such as IP evaluation, that's already announced, IP protection, and freedom to operate. So these are the three main sessions yet to come. I have added this slide as a kind of zoom into the stage gate process, focusing on the IP protection part, as that will also be one of our topics today. And just to see the timeline, it's covering a period that is a little bit more than 30 months of the whole innovation journey. And it shows the often used cost delaying approach for patent protection through the international route. Along this timeline, you see indicated there are three key decision points: the priority filing, the international phase, PCT phase, and the national phase entry. You will hear more about that later. It's a simple and straightforward concept, and yet this is frequently overlooked. At each of these milestones, the IP owner faces a decision, whether to invest further in patent prosecution and actually what kind of patent protection to look for. That decision depends on a structured evaluation, weighing the technology potential against other opportunities, competing for the same budget. Interestingly, the core questions at each stage remain similar, but the answers must evolve and become more precise, enabling more informed decision. This process is predictable, absolutely predictable, and everyone should know it. But in practice, however, many teams are caught off guard when their patent attorney suddenly calls them, asking whether and how to proceed. That happens when there is no process, no tool, and no preparedness. I have to confess, I would honestly be disappointed if that happened to any of you after this training, because this is one of the key takeaways. Don't let these calls catch you by surprise. Let's return to the big picture. As we discussed during the IP strategy day, efficient IP management is not rocket science. It's built on logical principles, many of which are actually codified in standards like ISO and DIN norms. Yes, hopefully not as a surprise, we have prepared a free open access article for you that introduces you to these frameworks in more detail. If you implement IP management best practices, you will develop tools, processes, and guidelines that improve the quality, the transparency, and the efficiency of executing your IP strategy. But there is one caveat. A chain is only as strong as its weakest link. That's why it's essential to understand the full scope of its components. And only in a helicopter view, but it should ensure that no key components in your IP management system is missing or severely underdeveloped. The good news, you don't have to do it all yourself. In contrast to IP strategy, where we advocated for having core competences in-house, here we see many aspects that can be delegated to an ecosystem of IP experts. Beyond patent attorneys and legal advisors, there are many external IP specialists that can help a business in many aspects of IP management. And don't forget, Stefanie is representing the European IP Help Desk, and they have a helpful guide published on their website, how to navigate this ecosystem of advisors, absolutely worth reading. And also for all the EIC beneficiaries, you should know that there is a support system in place that helps you to navigate through all those aspects. Now let me return to the practical side of IP creation. So IP creation being the first pillar in the graphic. At most of your organizations, researchers are already doing a great job creating IP within projects and collaborations. Some businesses decide to go a step further and accelerate R&D efficiency through more structured innovation approaches, like the TRIZ method, so TRIZ, TRIZ method, or design thinking frameworks. You can find excellent open access resources and professional training for both, or bring in external experts to support your teams in implementing that. It's absolutely doable and rewarding if you want to speed up the development of new technologies and fill your pipeline with new opportunities. In some cases, companies also scout for licensable technology to complement their internal R&D. That requires more skill and an onboarding process to overcome the typical not invented here syndrome. But it can be a very powerful way to save time and reduce risk. So if you want to learn more about that, go for the search term open innovation, and for best practices in open innovation, where exactly that is discussed. What is the not invented here syndrome, and why for many companies, organizations, it's not trivial to get technology from outside implemented in their own company. So there are just some little things to know to make the process more efficient. Now let's get more specific how to create commercial opportunities in day-to-day practice of deep tech-driven businesses. At the heart of it, it is about generating high-quality, well-qualified invention disclosures of R&D stuff. To achieve this, three elements are essential. One thing is awareness creation. Researchers need to understand why commercialization matters to your organization, to your business, and that they themselves can actually initiate and support that process. Second aspect, training. Researchers and support staff should be equipped with the knowledge to help move ideas closer toward market readiness. And last, but for sure not least, recognition and reward. These are two magic words. You never should forget them. If commercialization succeeds, inventors are usually promoted, rewarded, whether through revenue sharing, innovation awards, or inventors' days to celebrate success. These are all good practices. And these measures serve one main goal, and that is to increase both the quantity and the quality of invention disclosures. And finally, a reminder of what really matters. It's connected to the last point I had. Even with the best systems and processes in place, it's not about ticking boxes. It's about people. People that are motivated, enabled, and recognized. And yeah, we have here a slide that connects us to an earlier conference that we organized. I will not go into details, but the main aspect is that actually even research supports the observation that I've made many times, that a few key people deliver most. And that not only in terms of quantity, but also in respect to quality. An example is a study that was done about prolific inventors. 4% of German inventors listed on patents granted in the US are responsible for over 40% of the patents granted with German origin. This was one of the starting points for the panel discussion we had at an earlier HDB conference, where we discussed the human factor in intellectual asset management. You see the corresponding slide. The session got recorded and wrapped up in an article, so we can be short on that as well, and the link is also provided via the slide. I think it's an interesting read. I strongly recommend to have a look. So let's come to the key takeaways of this presentation. IP management is the execution of strategy. A holistic approach combines IP creation, evaluation, IP protection, and commercialization in a coordinated manner. It's not one step after the other. It's something that is done in an orchestrated way. Innovation is collaborative. Stephanie already reminded us from the IP Strategy Day, but this is also absolutely valid today at the IP Management Day. Everyone can innovate. No one can innovate alone. Another aspect is the proactive planning that ensures predictability. You hopefully will remember the timeline graphic that I used. And people are the driving force. And connected to that, recognition and reward are the two magic words in that respect. So I come to an end of my presentation, and for those that chase for the slides, I have added a few more for self-paced study, again as a kind of bonus program. And with a big thank you for your attention, back to you, Stephanie. Thank you.
Thank you very much, Thomas, for setting the scene and specifically breaking down how IP strategy translates into concrete IP management pillars and steps, and also for highlighting in particular the human factor, once again drawing our attention to the fundamental role of people as enablers and also drivers for intellectual asset management. We will now add another layer to the picture and turn to the technology side of things. So last week we heard about how important it is to know your IP, and along these lines one could say you also have to know your technology. So for crafting a solid IP strategy and consequently also for managing IP or your IP portfolio, it's essential to identify the technology champions in your portfolio. And we're very lucky to have Johannes Schaaf with us today, who will now tell us more about how to identify these winning technologies in your portfolio and then also assess your IP. Johannes is a patent analyst. He's also a member of the chief economist unit at the EPO, joined a while back in 2005 and worked on the newest BUSNet and patent analytics, IP score, PatStat, and regularly provides technology insight reports in the chief economist unit. A very warm welcome to you, Johannes, and the floor is yours.
Yeah, thank you, Stephanie, for the kind introduction, and welcome everybody to this session on IP assessment, how to identify the winning technologies in your portfolio. I will come back again to innovation management and valorization. What is it? How does IP assessment then relate to that? And I will have a look at this notion of what is the value of a patent and what is actually the value of anything and how to become then to the value of a patent. And then I will give you a short intro into the various evaluation methods and show you also the tool that the EPO offers for free that you might be using if you want to assess your portfolio. If you want to sell your invention, it's great if you can show that it excels on all the aspects that are necessary to have in the end a market success. So when we look into invention and innovation, this slide wants to show the basic differences here, because you may have a great invention which has big scientific merit, but it's probably not so easy to turn this into a commercial profit. So in creating invention is actually the process, in simplified terms, that you take the research money and try to generate as many as possible and as good as possible ideas from that. And innovation is then simply the opposite. You have the ideas, they are all on your board, and you have to select which one are the right ones, and you want to turn these ideas into money. And this is innovation. And to have successful innovation, it's simply not enough to have great ideas. It's the one ideas that also meet then a market demand. So when we look at this valorization process in technology and innovation management, we see here that we have research and development, we develop the ideas and the technological know-how, and then we produce our products, we bring them into the markets, and we have a continuous improvement process that generates new ideas and has top-on ideas and top-on patents that might be generated in that way. And this is more or less what we call innovation management. And the function of the patents in innovation management are on the one side of internal use and other side of external use. Internally, patents help us to define a good strategy. They can be really linked to that. The overall business strategy should have an effect on the IP strategy. On the other hand, if we have an IP strategy, it also guides our overall strategy. Then patents can have, let's say, they can increase the engagement of the inventors. They can block competitors' litigation, and you have a litigation deterrence that people go and litigate with you. If you have a nice portfolio, then you have something to bite back. Yeah, you want to generate a certain freedom of operation, freedom to operate, and then the patents give you a negotiation power if you go into cross-licensing deals, for example. They help you to have a strong financial asset. So for your company valuation, for the external image, for the intangible assets, it's very important to have them because they give you a brand reputation. And patents can really help you also if you are in the connected businesses to bring your ideas into standards. So standard essential patents would be a great pro if you had them in your portfolio. And then there is the external technology acquisition or external technology commercialization, which is in technology combined, where we have then open innovation, where we try to acquire them, avoid any non-inventor here problem, as Thomas already mentioned, and then sell ideas out. For the external use of patents, we can generate sales, royalty income. We have some pooling effects that we can benefit from, really collaborate well in open innovation, university industry partnerships, create joint ventures, spin-offs, and so on, and attract money. So we might be attractive for investors and IP-backed financing. The EPO supports these activities to attract financing in an own initiative, which is called the Financing Innovation Program. And here you see the microsite. Please have a look at this. And the services that you find there are twofold. On the one hand side, if you're interested in what are the startups that are worth investing in, then you can use the deep tech finder. You find the startups specific to certain industries, startups and universities you can find through the deep tech finders. And then we have also published studies. And these studies suggest that if you have, as a startup, prior IP application, your likelihood to attract VC funding is really much better if you have IPR. So if you have only trademarks, it's already twofold. If you have only patents, it's 2.4-fold the likelihood that you attract VC funding. And if you have both, it's 3.2-fold. So of course, it's best if you have a nice bundle to do that. So in one direction, it shows that if you have IP, you are more successful as a startup. And on the other hand, if you are a startup and searching for investment, then if you look at the investors, we did in a study here also a technology investor score where we rated investors according to their portfolio. What were the companies that they were funding? And we created a certain score here, the technology investor score. And the higher this score is, the more successful we can see the exits are. So investors that go into deep tech are themselves more successful. And then this helps you, for example, to choose also the investors that are the most attractive for you. So you find this information on our microsite. Please have a look. This might be quite interesting for you. So coming back to innovation value chain, we said we have a creation, we create the idea, and then we need to do the assessment, because maybe out of the thousands of ideas you have, there's only just one that will be a commercial success. And the question is, how do we identify that? How do we identify it, protect it then, and commercialize it then? So turning the ideas into money. So the basic notion that we have to answer here, two questions for these ideas. The first question is it possible to file a patent application? Yeah. And second question is, does it make sense to file a patent application? So the question, is it possible, is mostly is it patentable? And we know it has to be new, it has to involve an inventive step, and it has to be industrially applicable. So we have our databases for that. You can search in a BuzzNet, find whether there is state-of-the-art that stands against is that are tools that we are offering to help that to assess that even before you file with the EPO. The second question is the one that I want to focus on. That is the question, does it really make sense to file a patent application? Is there a commercial utility that can come out of it? And therefore, the basic question is the patent of any value? Now, with value, that's not such an easy concept. I mean, we have a good and it has a cost, it has a price and a value. And to show this more plastically, so more concrete, I would like to use here an example of a bottle of soft drink. The cost is maybe 20 cents. The price then already varies. I mean, you have the offer and demand question. So I pay in the supermarket maybe 50 cents and in the high gourmet restaurant 9 euro for it. What is the value then? The value is actually the individual utility that I take from this item. Yeah. So, and it will be different for me whether I'm just in my chair in the living room and enjoying this drink, or whether I'm in the desert and I'm thirsty and I wouldn't survive the desert if I hadn't had this drink. So in the end, what is the value? The value of any good and also patent is the future commercial utility you can take from it. So what is the value that we can extract in future from it? And if you now see evaluation and probably two people evaluating the same patents and coming to a different solution, you might wonder, oh, maybe the methods are bad, should come out with the same answer. No, not necessarily, because the value depends on many things. For example, it depends on who uses it. So the value exclusively used by the owner is a different one. If you develop this, it fits into your line and you can extract a certain amount of money with your product line, with the extra sales that you can generate with this patent due to the patented invention. Yeah. Then if you are licensing it out, it may be for one licensee, it might be very valuable because he doesn't have to do much. He just changes a bit the production parameter and use your invention. Yeah, so puts a new substance into something, or the other one has to build a new line to make it work. So it's depending really also on the specific licensee and the circumstances, how valuable this patent is. Because if there's a lot of cost, then of course the value is not so high for the patent. And then for a bank, you can only use it as a collateral. What could the bank do with it as a security? They can only sell it, so they can't use it themselves. And then there is another occurrences, and this is the big numbers that we see sometimes in the press. That is the value of a company blocked by a patent. This was the BlackBerry case where 600 million were paid for a patent that was partly later revoked. So the question was here, what was the value of this 600 million US dollar? In the end, it was a bit, if they didn't pay that, they would have been threatened to get out of the market because they couldn't bring their products anymore into the market. So in the end, the value of that patent is more or less the value of the market. And no bank would have given this as a collateral. No licensee would ever have paid that for the patent. So these are specific circumstances. So as I said, it depends very much on the occasion and who is using that. And there's another dynamic, and it's the dynamic over time. So this is the PCR invention, which helps to reproduce a DNA. And when Carey Marlis invented that, he got a compensation of 10,000 euros from Cetis, his employer, but Cetis sold it later for 300 million to Roche Diagnostic because this multiplication of DNA was the key to the biotech revolution. And so the value of that patent rose as the application possibilities of that technology rose again. And then at a certain stage, it plateaus. And then at the end of the lifespan of this patent, of course, it declines because the private value declines because the patent protection is going to expire after 20 years. So, of course, when we look at the public value of it, this patent has been cited in the meantime 7,000 times, indicating that many, many people use this and build on the technology. So the question is, how do we identify patent ideas and patents with high value? Sorry. For own products and service for technology commercialization. So how do we do this evaluation? And there are several methods. So we have quantitative methods and qualitative methods. the quantitative methods, and there is a method that is called net present value, where we are looking into future incomes, the market value, where we compare with the market price of similar patents, the cost value, how much did we spend in it, and then there are computer-generated estimates where we use some information from the patent databases like forward citations to come to a valuation. So the basic outcome of a quantitative is that we get a number out, the patent worth 500,000, for example. In the computer-generated estimates, we don't get a real number out. We get only something like a basic patent quality out, and we say maybe it's worth 5 average patents. This would be an outcome of that. I'll explain later a bit how this works. The qualitative methods, they look at the dimensions that already Thomas Bereuter mentioned, technology, market, legal issues, finance, and strategy, and we look how the technology scores with regard to these aspects. The assessment there is not a one-dimensional on a money basis, but we find something like a patent protects the technology of strategic importance in an attractive market. It can be enforced efficiently, but significant investment is still needed. So we get really a hands-on exercise. What are the problems? Where can we explore? What are the advantages? So net present value, we are looking into future incomes. So we are looking into what are the future incomes, and we discount them with an hypothetical interest rate to today's value. So we want to have, if we get money, we want to have it rather today than in 10 years' time. So you have to discount future incomes to today's value and also expenditures. And you simply then build up the sum of the both, the discounted cash flows, and then you get a quite simple decision matrix where you say, if the net present value is bigger than 0, then you do it. And if it's smaller than 0, then you don't do it. Of course, it's a very simplified way of looking into this, because we have just one patent is this value, the other a bit higher, so let's take the higher. But we do not really know, does it really fit good to our strategy? Is everything covered there? So simply relying on this one-dimensional thing would be probably not enough. And then there's another problem. For the net present value, the predictability of the cash flows. So we make a nice business plan where we see, okay, we will sell so and so many over time. But of course, these predictions are, since they involve the future, quite insecure, and our net present value will depend on our confidence how well we will perform in the future. So the identification of cash flows is also an issue. So what belongs to which? You're looking into different scenarios to make it more complex if you want. And it's also a bit difficult to see synergies and strategies. For example, employee satisfaction, like I mentioned earlier, is one of the benefits of patents. When the inventor gets a patent, he's happy, and probably more, or he or she is happy and more productive in the future. So those aspects are difficult to account for if we simply look at the money terms. The qualitative evaluation that we do with IP score, I mean, we do this net present value in IP score, but we do also a qualitative analysis where we look into the various areas. And there we are asking questions like, what are the marketing options? Is there a known market? Do we have an emerging market? What is the market growth that we see in this area? Because if there's a big growth, we can grow with the market. It's an easy catch. If there is already a saturation, then of course it's more difficult to perform there. Can we reach an additional sales price with it? Can we get more money than the competition with it? So such analysis with such a scoring model, we can really accommodate for all the complexity because we are looking in all these strategic aspects. It's easy and fast to understand. It can really facilitate the collaboration of the various units in an organization. For example, the marketing department, the finance department, the legal issues, and the technology. And sell this also in an easy way to our management who's looking after the strategy. So we don't do calculation of profits here, but we get a very comprehensive view on it. So now a short view into the tool. So this is the tool. You can download it from the website. It's an Excel sheet. You're asked questions like, what are the marketing options? You answer them. You input also your numbers, and then you get an assessment of the patent. You can also put your financials in there to scale the patent, let's say, because we don't know, or the tool doesn't know if you have a big business or a small business, and this scales it actually to the value so that you can get really a money term back from the tool. You can adapt it, that will be indicated by the tool, and then you get outputs like here, a rudder chart or the future income charts that you see in the middle where we have expenditures if we do the patent in the beginning. So we are in the red curve, let's say below 0 and then being above 0. And this allows us to calculate then, is it a good idea to do the patent or not? If you don't do it, you have simply the red development, the green development here. And if you don't do it, you have the green development. And if you do it, you have the red development where you have further investment in the beginning and bigger returns. You also see the risk and opportunities for each patent and technology, which helps you to assess what is a good patent for you, for your business, and the future viability of your enterprises. So I hope this gave you a bit of an impression what tools are available for IP assessment, what is the best way forward here, and how IP Score can be used to help you identifying the winning technologies. And with this, I would like to end. Thank you.
Thank you very much, Johannes, for this very concise overview and showcasing the different options that IP Score provides. When we talk about winning technologies in Industry 4.0, that's how we opened last week, we talk very much about things like Internet of Things, artificial intelligence, 5G. Hence, essentially, we talk about digital inventions. And we've already seen a lot of questions coming in last week towards or asking the question, how does this really, or what does it mean, digital invention? How can I protect it? And these are the questions that our next speaker, Rainer Kaysan, will now tackle. Rainer is the head of the Patent Department at the European Patent Academy. He holds a master's degree in aerospace engineering and business economics. And he joined the EPO a while back as well, in 2006, as a patent examiner, carrying out lots of prior art searches and chairing position proceedings in that role. And as said, he's now heading the department. So a warm welcome also to you, Rainer, and we're looking forward to your presentation now.
Super. Thank you, Stephanie. I hope you can hear me. And
Yes.
I will also share my screen now. Let me know if you can see it.
Yes, we can see it.
Perfect. So welcome everybody also from my side. Welcome to IP protection. And as Stephanie already said, last week there were a lot of questions already heading into the direction digital innovation, digital in patenting digital ideas or ideas from the digital world. So my presentation today, so this session we do is has this kind of this twist looking into the digital world, not IP protection in general. So to accompany the questions we received in the last days. So it's a very highly relevant topic, as I said, in this digital economy. As we all know, innovation is not limited to physical machines or chemical formulas. Currently, we are seeking an explosion, actually, of innovations in software, AI, Internet of Things, data platforms, inventions that certainly look different compared to traditional technologies we know from the past. So there, the question, as Stephanie already correctly raised, is what can be patented in this world, digital world? What are the alternatives? Are there alternatives to patents? Maybe there is something we should rather keep secret. And also important, what are the risks if we get it wrong? So in this session, we will break down how IP frameworks, like, for example, the one at the European Patent Office, are adapting to meet this new challenge, and how businesses, particularly also SMEs, can build what we call a mixed layered IP protection that go beyond just filing patents. Along the way, I prepared some real-world examples for you, so I promise it will be not too boring. AI-driven maintenance solutions, smart kitchen devices, which I guess most of you know, and we will discuss how these innovations were protected and why that way of protection very much matters. So let's have a quick look into the agenda. So I like to start with giving you a bit of a big picture of digital inventions, some context there. Then we will compare the digital with the more traditional inventions. If I say invention, I don't mean invention in terms of a granted patent. I would say an invention in more generic term. You know that if a patent is granted, we have assessed an inventive step. We come to that later. So just for you to compare, if I say digital invention, I don't talk about a granted patent yet. So if you compare these different dimensions, digital, more the analog, classic, mechanical engineering, you will discover that there is what we call a gray area. We come to that later. Then also we look into the driving reasons why protection, particularly in digital innovations, is so important, which we call the ease of imitation. Then we will have a detailed look into the EPO's legal framework. And there you will come to this term of computer-implemented inventions. And following that one, how we assess this potential invention, we have an approach which we call the COMVIC approach. And this is combined with two hurdle tests, and we are looking into what we call technical features. Together with you, I will deconstruct a real patent claims or real world example, walk you through that. So you show how this test is applied in reality. And then afterwards, because then this was really looking into patentability, we will also look into alternatives, as I said before, alternatives to patents. And then we look into the two case studies. Well, let's dive in. Let's begin with a big picture. So digital inventions. We are in the middle of what we often call Industry 4.0. That is a wave of transformation where digital technologies like Internet of Things, AI, big data, and so on are being integrated into products, solutions, also having a physical aspect. So physical systems, mixed systems. This integration is creating really smart and connected environments that are reshaping manufacturing, logistics, healthcare, and many other sectors. So actually, they are really having a big impact in our day-to-day life as human beings. To give you an example, as we can see here, AI-driven predictive maintenance. Here, for example, General Electric developed something they call Predix. That's a platform which uses real-time sensor data, so they can predict if a product, a medical product, for example, is about to fail, so anticipate failures, and then can already give messages to reduce downtime. Or blockchain-based supply chains. So here, for example, we have IBM's Food Trust that helps to ensure full transparency and traceability of nutrition. So they say from farm to fork. Or what I like personally, because I have an engineering, aerospace engineering background, is a digital twin. So Airbus, for example, uses that. So you have a virtual replica of a real physical product, like an aircraft, and you work on this virtual replica for simulations and optimizations before actually you produce physical prototypes or in parallel. What's important to realize is that these digital inventions are rarely just purely technical. They very often, or I can say they always combine hardware, software, but also business logic and UX design. Some of you maybe already know that what I just said, some of these are non-patentable under the EPC. I come to this point later. So, but all in all, this makes protecting the whole ideas, the whole inventive concept very complex. So the challenge here, which is at the same time also the opportunity, lies in identifying which parts are technical, hence patentable, and how we can structure a patent application in a way that best reflects the scope and the value of the invention. And if you have a good patent attorney, also the broadest scope possible to protect the invention. In addition, we need to look at options to effectively protect the remaining features, which necessarily leads us to what I said, this multi-layered IP approach. So to summarize, in the digital age, innovation no longer fits a single mold, as we knew it maybe from the past, from traditional inventions, like a new engine or a chemical compound, because they are at least intangible innovations. And while these are often groundbreaking, there's always the fundamental question, do they qualify as an invention in the sense of patent law? Particularly here, I'm talking about European patent law, so EPC. Maybe they are just clever ideas, but not enough technical features to give reason for a patent. So this is where things become tricky, because many of these digital innovations, they live in the intersection between a real technical solution and something abstract. That could be a mathematical formula, algorithms, business methods. And then that makes it very difficult to see if they're eligible for patent protection. So question is, how can we tailor this in the way that we protect IP, although they are pretty complex? Or in other words, how can we ensure that our valuable assets pass the challenges of the IP framework and our digital innovations are probably protected as good as we can do, as we can get? I told you in the beginning, we have something which we call the gray area. So here we say digital innovations to blur the line between what is really technical, so technical features, and abstract. So what is technical? So if you look at the left of the slide, traditional inventions, here, like an engine, which I mentioned before, you have clearly technical features. They have a physical form, you have a measurable effect in the real world. This makes it relatively straightforward to define their technical character, or what I said in patent language, technical features. On the other hand, digital inventions can be more difficult to define. Think about an AI model that recommends products, or a mobile app that helps users to manage their finances. Most of the invention lies in an implemented code. So, but then do they really solve a technical problem, or is it just clever coding? So there we have a bit of a gray zone. Sometimes these digital innovations, they may look technical on the surface, but underneath they are reduced to a mathematical algorithm. So there we have to look. Before we go into this in detail, so how to look into that and the computer-embedded inventions, a question I like to ask, why is it then so important to seek protection, particularly for digital innovations? And here, allow me to point you to one of the leading business risks. And this is that digital innovations are very often easy to copy. Unlike a complex physical product like a jet engine, digital innovations often exist of codes and algorithms and UX design executed on a computer that can be reverse engineered, replicated, or maybe slightly modified with minimal effort and cost. So for sure, this does not always apply. We come to this later when we talk about trade secrets and when we look into the case studies which are brought with me. But for now, think of a mobile app. Once it's public, it's relatively simply for competitors to deconstruct it, to deconstruct the features, and to replicate the functionality. Sometimes with just some minor reverse engineering and changes, and then they can bring a product to the market very quickly. So this poses, as you know, a serious business problem, because it quickly takes away the exclusivity of your product, which weakens your market advantage. And if you are unlucky, it limits the income even to extent that you are not even able to return the R&D investment. So we can agree that this is a very fast-moving sector. So time to market is short, but unfortunately, time to copy could be even shorter. That's why the role of IP, and particularly EPO's framework for computer-embedded inventions, is really paramount here. So I think inventors need a clear and predictive criteria for what counts as a technical contribution over the prior art, and they need an enforceable patent right to protect the value they created. So what is a computer-implemented invention? As we talked about it already now a couple of times, CII, or computer-implemented invention, is an invention which in which at least one technical feature is implemented by means of a computer network, or other computer kind of apparatus. So to give you an example, a control system in an autonomous vehicle would be such a computer-implemented invention. A prerequisite for patentability is that the technical feature must solve a technical problem in a new and inventive way. So looking into inventive. So patentability needs this step of being inventive. So an idea must be inventive, otherwise you will not be granted a patent. But let's go a step back, because maybe some of you heard already that, oh, at the EPO, you cannot get a patent on software. So let's have a look, because we're talking about digital innovation. There is the Article 52 EPC. So there's only one slide about the EPC, so that you don't worry. We are not getting too much into patent law. But this Article 52 is very important, because if you look into the paragraph 1, it says that patents are granted for inventions in our technical field, or in other words, patents are granted for technical inventions having a technical feature to solve a technical problem in a new and inventive way. So if you think now of your software, you think, oh, okay, it seems to be good. So we are good with our software. But then you go further and you see in Article 52C that this article, or this paragraph of the article, excludes program for computers. So the EPC is different here to other legal frameworks. If we, for example, look to US patent law. So, okay, it seems we are not good any longer. But fortunately, if we go further down, there is Article 52.3 EPC, and that says that patentability of programs or computers is only excluded as such. So that means that we are good again or not. So we have to look into that as such. What does it mean as such? So if we look into as such, we have to differentiate what is technical in a term of technical features and what is non-technical. So we first have to distinguish between this technical features and non-technical features, and then we focus on technical features if we have a mix, which we have almost every time we have a mix when it comes to computer implemented inventions, and we focus on the technical features. So I can give you some examples of non-technical features or non-technical purpose, which would be excluded. For example, a computer program for calculating prime numbers. This is a clear mathematical algorithm, which is excluded. And here, the second example is a bit more than the algorithm. It's also providing visual attractive four-color graph design. Displaying information per se is also not patentable. This is rather going into design, UX design. We come to this point later. And if we look into the technical purpose, on the other hand, so we have a method and it's also calculating. So you can argue, oh, there's again an algorithm, but here it's clearly interacting with the outside world. So experimental errors, calculating, giving results. So that's a bit a different thing. It's the same for the computer implemented method. Sorry, this was automatically. For a vaccine candidate. So here there's also clear interaction with the outside world. So when is a program patentable then? So the key point is that, as I said, not all software is patentable, but also not all software is excluded per se. Only software that does not contribute a technical effect to solve a technical problem. To be more precise, if a computer program provides a further technical effect so an effect which goes beyond the normal functionality, what you can expect between hardware and software, then it could serve as a ground for a patent. Here are 3 examples. One is a control of a physical system, like a robot arm, then processing sensor data, which is also then interacting with the outside world, like heat distribution in a building, or advanced hardware interaction, which goes beyond what you would usually expect in a computer. So here we have the example, we have an optimization of multi-core processor. It can get, however, it can get a bit tricky. These are more or less straightforward examples, but it can get more and more tricky and not so easy to see if this is straightforward or not. In the next slide, we have some other examples for straightforward technical features. So image compression, you take an image, you have an algorithm, yes, but you have a clear connection to the outside world. You have an entity you work on. Same with network protocols. So you there you check and control the communication between computer entities in a network. Data storage also, you control how we access data, for example, on an SSD. But then it goes into maybe AI models, the user interfaces. That's a bit tricky because per se there's nothing you can grant a patent on, but maybe it depends on the context. So, but this is not straightforward, and that's why independent, how straightforward or not, there must be an approach to clearly determine if this potential invention is ready to be or eligible for a patent or not. And for that, we have at the EPO something we call the COMVIC approach. So as we learned, most of these computer implemented inventions, they are a mixed type invention. They contain technical features and non-technical features. For example, a claim might include a processor and data structure, which is clearly technical, but maybe also a business rule, an algorithm or something which in itself is not technical. So this 2-step approach, which is called the COMVIC approach. Why? Because there was a T decision at the EPO from the EPO's Board of Appeal. And COMVIC was the name of the company of the patent applicant in this case. So the 2 steps, so the first one is the invention must have a technical character. So very often by formulating a claim in a way that is a computer implemented and giving this features, that's already a strong indicator here. So if you, for example, have a drone navigation system using GPS data, so you see already there is something like it's implemented, computer implemented. So that per se sounds very much that this is eligible. But if it's only about a business method, like a dynamic pricing model or something, that is excluded as such. So that is the first step. Then for the second step, we have to look if the invention involves an inventive step. So that means a technical contribution over the prior art with technical features. So I mean, I'm focusing now here on inventive step, but as maybe most of you know, to grant a patent, the invention must be at least new and inventive. So there's also the novelty aspect. So if something is not even new, you don't even assess inventive step. So that is here a bit as a background. If you know more about, want to know more about novelty, it's Article 51. And that means that the combination of features was not available to the public before the date of filing of the European patent application. To give you a bit of an overview in a flow chart how that works. So we have a claim, and I will now come to an example in the next slide. So we have a claim, a claim of a patent application. you then, as the patent examiner, also identifies all the features and then divides into what features are technical and what features are non-technical features. So, and then for inventive step, we only look at the technical features. Interesting to know is that, as it's also shown here in this graph, the non-technical features are not considered when we look into inventive step, but they're also not ignored completely, because they will be taken into the account when we formulate the technical problem, for example. And they're also treated as constraints the engineer must work with when you implement the invention. So they have an impact, but not as a direct feature to assess inventive step. Let's look into the example I brought with me. It's a computer implemented method for a shopping app. And you don't have to read through all of that, because that already the examiner did. And what an examiner does, usually deconstructs the claim and split it into the individual features. And this is what we see here now. This is called the feature table. And here you can see these are the different features of the claim. And you see already the claim includes both technical and non-technical features. For example, selecting products, defining shopping preferences. These are clearly business ideas or business methods, so they are non-technical in the sense of the of patent law. And then we have something which is technical, displaying information on the mobile device. But here you learned already that this is excluded from patentability, displaying information. This is also here merely a standard hardware-software interaction and nothing really contributing over the prior art. On the other hand, we have use of a server, transmission of data, and the implementation of a cache memory. And these are technical features. So as I said, we now look at the technical features. And the examiner at EPO would then see that all these features, and also the combination of features, is already known in different prior art. So if this would be known in one and the same document, then it would be even taking away the novelty of this idea, of this invention. If it's distributed, then you have to look into inventive step and argue rather along the line, does this involve an inventive step, or is this not obvious? And in this case, the examiner decided this is actually obvious in the light of the prior art. So therefore, no inventive step under Article 56, and that means no patent granted on this idea. That leads me to the question, what can we do in this case? And if you joined the IP Strategy Day last Wednesday, you already saw how to combine different IP rights to better protect your idea. So here in this slide, and also in the following slides, I will further build on that with here in my presentation with a specific view on digital innovation. So first of all, what can you do if your digital invention is not patentable? Well, that doesn't mean you can't protect it, as you know by now. You just need to look a bit beyond patents. Here I gave you some examples. Trade secrets are often the go-to option for protecting elements like source code. Then we have design rights. So for example, classic one is UX design. And that is more a visual element you can, which you can protect via this design right. And it's quite nice because with this you can protect the look and feel, which is also something very important to a digital product. Remember that displaying information per se is not patentable. And let's not forget copyright. This is a right which automatically applies to software code and databases. It's the thing is, it's not protecting the functionality, the broad functionality, but at least it protects the expression of the author. So that means the way you code it is, like, let's say, how you structure your code and how you write your code would be protected under copyright law. And in a broader context, trademarks also play a role as an additional IP layer. So concluding this slide, the smart way is to effectively combine these rights, these IP rights to your product. And as we will see now in our 2 case studies, many of today's successful companies use this mixed IP rights to protect the full scope of their innovation. So it's not only about patents, it's about combining patents with other IP rights to create a full protection and tailored to your product. So let's look into the 2 case studies I brought with me. So these are both companies that successfully applied mixed IP rights to strengthen their market position and ensure that their products offer unique selling points to the customers. The first one, and I guess this product is known to most of you. This is Thermomix. This is a kind of over the years or over the decades became an iconic smart kitchen appliance from Vorwerk. So it's not what it used to be in the very beginning. It's kind of a heated blender in the old days. So it's no longer a heated blender. Now the newest version is really a connected software-driven device. It's a kind of a platform that combines the classical mechanical engineering with digital intelligence. So this Thermomix case showcases that today's innovations blend physical parts with software, algorithms, and design. So we learned already that part of these elements are non-patentable, particularly if they lack this technical contribution under EPO rules, so under the EPC. So how do these companies protect the full value of their products? And here, as a summary again, these are the different means of IP protection: patents, trade secrets, design rights, trademarks. Let's look how Vorwerk does it with the Thermomix. So as I said, the Thermomix is a perfect example of how to protect a complex digital physical product using layered IP protection. So Vorwerk patented the core hardware and the embedded systems, so for example, the heater, but part of the magic, so the logic that controls the cooking processes, is kept as a trade secret. On top of that, they use design rights to protect the look and feel of the interface and also the look of the whole appliance. And as many of you know, the trademark stands for quality and reliability of the product in the past and also for the years to come. So let's break it down. Patents are used to protect not only the mechanical components of the device, but also the embedded technologies, so the sensors and control modules. At the same time, the more sensitive elements, so that let's say the heart of their ideas, like the cooking algorithms and software logic, they are kept as a trade secret because I guess Vorwerk decided that it's hard to reverse engineer these parts. And this ensures that they maintain this key competitive know-how. As a side remark for trade secrets, you really have to make sure that they stay confidential, because then you have no further protection. To protect the look and feel of the product, including the interface, they use design rights, and they also use trademarks for the kind of the overview, the overall brand identity and marketing purpose. So what makes this case especially relevant is that despite the growing competition, and maybe you also read about this Vorwerk Lidl case suit and so on. So despite this growing competition and imitation attempts by this mix of IP rights and clever marketing, Forward has maintained the strong market leadership. And this is kind of a textbook case of protecting a product that spans the digital and physical worlds in a very efficient way. We have some time left, so let's quickly look into the second example I brought, and that is something a bit more from the traditional mechanical engineering side. So Vilo is a traditional German pump manufacturer at a certain moment. So Vilo is a traditional German pump manufacturer, and at a certain moment, they realize that there's a saturation on the market. They are a bit stuck in their portfolio, and so they decided, which is very risky, but it paid off, to undergo a digital transformation of their business. So rather than just selling hardware, they decided to embed Internet of Things sensors into their pumps, enabling real-time monitoring of performance. And on top of that, they introduced a predictive analytics, which essentially use data from the sensors to forecast failures or inefficiencies. And this can then offer a bundled service to their customers to optimize maintenance management. So as you can see, this was more than a technical upgrade. This was a paradigm shift from a sole product seller to a holistic service provider. And that created a new value proposition. So selling smart services and not just a pump, just a simple physical entity. So let's look into Vilo's digital transformation. So how did they do that? A bit as Vorwerk, they also use mixed layered IP protection, securing patents for the smart pump hardware. And they also, again, use some trade secrets for the algorithm behind the predictive models. So first, Vilo secured patents, and this also includes the Internet of Things enabled pumps and sensors and communication modules, and also the overall system integration. So these patents protect the technical architecture and prevent competitors from copying the physical smart components or the way they connect, even how they connect to the cloud infrastructure. But the core intelligence of the digital part of the invention, so the predictive algorithms that analyze the data of thousands of pumps to detect early signs of failure. So there's also an AI algorithm behind, a self-learning algorithm to better predict. And this has been kept as a trade secret. Why? As I said, a bit similar to Vorwerk, by not disclosing these algorithms through a patent, Vilo ensures that the core of its data-driven service remains secret. So it's then protected from reverse engineering and publication. And as I said before, there's always the risk of a trade secret that if you have a confidentiality breach, we have no protection at all. So there is a risk with a trade secret. So you have to be very careful if you make use of this IP strategy. So I think Vilo is a great, this case is a great illustration of how IP supports the whole business or is a driver of a business transformation. So by protecting both the physical product and the intelligence behind it, they were able to move from this simple hardware pump manufacturer to a really holistic service provider. And that creates actually and just another dimension of recurring revenue streams. So here as a kind of to have it in one sentence, this is very important because it shows that this clever layering of IP rights is not just about a legal protection. Here it actually enables a whole business transformation. I'm running a bit over time, so I keep it rather short. So what these cases teach us. So layered IP protection is essential. We saw how you can do that and the different layers you can build on. And then IP enables a complete business transformation, new innovative concepts, and defensive and strategic value is also something which is very important here. And what is also important for you as being in a startup or SME or a small spin-off situation, this is not a huge multi-billion company. This, what I showed you, also applies to SMEs and smaller companies for sure. So to summarize, and this is my last slide, digital inventions often blend technical and non-technical features. Not everything is patentable, but still much can be protected. The EPO applies a clear and consistent approach, what we now learned with computer-implemented inventions. And there's also a clear instruction how this is applied in the guidelines. And it is possible to patent computer-implemented inventions, but only if they solve a technical problem using technical features. And finally, we often see in our days a mixed layered IP protection, particularly when it comes to software and digital innovations. This is essential to really safeguard all aspects of your innovation. And with this closing sentence, I would like to thank you all for listening and give the floor back to Stephanie.
Thank you very much, Rainer, also for speeding up, which means that we still have some time to address some Q&As. We've been busy, our speakers been busy answering your questions already on the fly. So I will pick a few to hopefully reflect a little bit more on that. And we maybe we start with you, Rainer, before I also turn to Johannes once more. So we had this question, of course, very much, okay, if I can protect an algorithm, but then I can't protect the usability, for instance, of that or code. So what's then the benefit of that? How can it still be beneficial for me to do that? Maybe you can share some thoughts and experience also, but I think it's not the first time that you hear that question.
Yeah, with pleasure. So actually, I would say it's rather the other way around. So the EPC is very clear when it comes to mathematical methods and algorithms. So you will not get a patent on that. But, and that is what I showed on one of my slides. So this is excluded per se, but actually it's the other way around. So if you can prove that this algorithm is embedded in a whole inventive concept, which also has technical features, then you can protect the whole concept, including these non-technical features. And that actually is a benefit, because I maybe didn't come across very clearly. The non-technical features, they are ignored when you assess inventive step, but they still play a role. They will not be ignored when the examiner looks into the patent claim. So with cleverly also building these non-technical features around for your patent claim, you can get protection for something very strong, particularly if you put it into practice. And this is actually, in the end, my personal experience is this is actually what counts for a company, not the abstract algorithm, because with that you don't make any money yet. You make the business case is mostly the implementation of your idea.
Yeah, thank you very much for clarifying that. I think another interesting question was also the question of enforcement and infringement. What makes it more, is it more difficult with digital inventions if something is hidden, you know, in that kind of invention? What's your opinion on that? So I remember there's one question that how could I prove that a competitor is using my invention in the software control part of, for example, a robotic arm? What's your experience with that when it comes to enforcing that kind of protection as well?
That's very true, and that's even true when you don't look particularly into digital inventions, but if you look into inventions which are defined by a method, for example. So from my many years as experience in aerospace engineering, you had very often product claims which clearly define a physical product, and then that makes it easier, let's say, to go into infringement, into procedures to sue for infringement, because there is a physical entity. And I have cases as chairing opposition cases where people brought actually the product to the to the proceedings and showed them, look, this is a product, this is infringement. But when it comes, for example, to methods, it's very tricky. That's why if you have a good patent attorney, they always also try to protect physical entities with it, so that you have something which is easier in a case law. And they're also now making a bit of advertisement to the unitary patent. Here, at least, we have something like a harmonized approach, which makes it then easier for you to defend your rights because it's a common court. So you don't have this issue that you have national courts and they maybe all have a bit of different view on things.
Mm-hmm. No, I did. We actually received also a follow-up question just now concerning a bit of copyright in the mix of IP rights that exists and how that is useful in as part of the multi-layered IP strategy that you mentioned. Maybe you can comment a bit more on that.
Yeah, it's I mentioned it because you have it, as I said, copyright is something you don't have to apply for.
Yes.
A copyright you do or you get already by creating your art. Compared to the other IP rights, I would say in this context is rather a weak right, because it protects the way and your style and your code. But if you're a clever coder or even using now AI, you can alter the code in a way that it's maybe hard to recognize the original author. So, but I mean, as I said, it's a kind of a free copyright. I would still make use of it, particularly if you manage to code in a very clever way, something really where you say, this is not how other people until now coded so far. So that's where I would say, yes, why not? I would then also secure this right.
And maybe just one question for this one. So looking also something that I see in the questions a lot, the differences between the US and EU. Maybe just a brief comment from your end concerning patentability and the checklist for patentability. Are there major differences between the EU and the US? And how is that potentially also to be evolved or updated as we go along and as we see more technologies of that kind emerge?
Yeah, I mean, patent law evolves over time because we have to go with the trend. Maybe you remember there was this decision about an AI which filed a patent application. So that was an interesting one. And there, if there are kind of disruptive things happening in patent law, then yes, the Board of Appeal, or in that case, it was called the Dabus case. So Dabus was this AI and indicated as an inventor, and it was an artificial intelligence. And here the legal Board of Appeal decided, it was a J820 decision, that in Europe, in front of the European Patent Convention, so considering the European Patent Convention, an inventor designated in a patent application must be a human being. So there you have already different ideas in different regions in the world. You have to be dynamic to go with the trend. But I mean, this is not my personal opinion, because I'm at the European Patent Office. I think our approach to patenting software is more, let's say, reliable, and also a bit more, as it is more, puts more constraints. You have to put a higher effort to get your patent, but I have to say that also has an impact on the patent itself. So I don't want to say that there's less quality patent or something, but that it's a different approach. And I have to say, I'm pretty happy that in Europe we don't give a patent on a green knob on a screen or something, or a green button. So but this is my personal opinion.
Okay. No, thank you so much for that. And I would like to use the remaining minutes of that session to maybe ask Johannes to come back to that virtual stage. I know you've been also busy typing and answering questions already. I just felt that lots of the questions that we've seen are also about, with all the methods that we see for IP evaluation, how do I actually choose the right one for me, and where do I start with that? Any tips from your end, how to assess what is, the best method for you know, for my end, for my company, for the things that I want to achieve.
Yeah, since we have an own tool, it's of course a bit I'm a bit
Well,
skewed in this area,
well,
so I
fair,
would
fair
promote
enough.
my tool.
Yes. Yeah.
But in the end, you know, I think in the end you're asking several questions, and I think I think one should start with something that exists already. So why not starting with something that some people provide, and we have. I mean, we provide an Excel tool. You have a list, yeah, and then you use it, and you find actually for me these 3 questions are the most important. The rest I don't know, or it's difficult to assess, or whatever. So pick the ones that are the most important for your business, do some structure to your process and apply that. And that's already a lot better than just, let's say, having your gut feeling. I think this is a good one, this is a bad one, let's do this or that. So I would simply start with something existing, adapt it a little, integrate that in a process, make a regular review. And I can tell you it's better you have these 5 questions that you answer to everything than if you don't have a process and if you don't do it systematically. And then you can increase that later when you see your system is not enough, then you can make it more complex. So I would kind of, if I'm open, I would simply go for simplicity and try to do the obvious first and then more complex things on top of that. That would be my basic tip. And Thomas, you have been in this business. Maybe you are even better to answer
Chime
this
in.
question.
Yes.
Yeah, so really, yeah. You are muted, Thomas.
I'm happy to add to that because one thing is to make the right decisions, but the other thing is to communicate about the decisions you took. Because often, you know, not the first invention of an inventor is the big hit. Maybe it's the second, the third, or the fourth, and you want to make the inventors understand why an invention disclosure is positively seen and why is one rejected. What are the main reasons, pro and con, so that the inventors they can improve upon, and they also understand and accept your decisions taken. I think that's a very important aspect to keep the motivation high and to improve the system over time, that everyone that contributes within your organization does the best effort and understands why this was taken and the other one was not taken. I think that has a lot to do with the intrinsic motivation that people have to contribute to the success of the business. And so it has a strong communication component, and communication then needs to be done somehow. And the tool, Johannes, that you mentioned, that EPO-EIC is a nice thing because it helps documentation with the radar profiles and with a structured approach. Then it's becoming more transparent. Yeah, I think that adds a lot of value.
Thank you very much, Thomas, for adding that to the conversation. So I keep an eye on the clock, and we're taking a break now for 10 minutes, and we will start at 4:45 again, welcoming Kaysan Soltmann then. So see you in a bit, and then we'll hear more about freedom to operate assessment. Thanks, everyone, and to our speakers in particular.
Thanks for your great questions. Thank you.
Yeah, thanks, everybody.
Thank you.
Welcome back, everyone. And I see Christian already joined me here. So as said, we will now turn our attention to the assessment of freedom to operate. Freedom to operate is a crucial concept in the IP world because it means being commercially safe to make use or sell a product without infringing on third parties' IP rights. And hence, it's a fundamental basis for your business development and business activities altogether. So as said, I'm pleased to welcome Christian here again. He was also part of last week's speakers. And Christian is also a member of the Chief Economist Unit at the EPO. He's a patent analyst. He joined the EPO in 2013 and is currently involved in numerous patent analytics activities, such as the creation of EPO Patent Insight reports, as well as EPO technology platforms. So a warm welcome back, Christian, here with us, and please go ahead.
Thank you very much, Stephanie. It's a great pleasure to be with you again. As Stephanie mentioned already, I'm going to provide an overview of freedom to operate assessment, context, background, the main steps. Time is limited. I cannot go into the very details of this assessment, so it aims to be a general overview. And if you would like to see more, we have more slides in the set of slides you will be made available after this presentation, or you see the individual steps. Generally speaking, freedom to operate assessment is very comprehensive and also demanding topic, so you cannot expect to become familiar with this topic and the nitty-gritty details within a few minutes. It takes days, weeks, and sometimes months to really to gain some experience. But you don't need to, because in the end there are experts available, patent information specialists, legal experts, patent attorneys, for example, which can take over the duty and offer a high quality service. And it's worth it, this investment for these activities, because it's an essential part of the risk management in your company or in other institutions. And this afternoon, I will talk about the 7 Ws. So first of all, I will explain the reasons why you should consider freedom to operate assessment. Second, the parties involved, the critical features of the product or process in question to be considered in order to define the scope of such kind of assessment. Then the timing when you should assess the freedom to operate, where you don't need to do it everywhere in each country worldwide. You can set the focus on those countries where your market will be expectedly, or where your competitors have their main area of operation. And then in which way, as I mentioned, I cannot go into the very details, but I can provide you with an overview of the operating process, the individual steps to be taken in order to make this assessment, by which means, again, it can only be an overview. I will present some information on tools and services and databases you may use, and also complemented with some other sources, mainly the Deep Tech Finder the EPO has created to retrieve information on European startups mainly. Yeah, what comes next? What options you have after you did the assessment and you found potentially infringed IP rights. Okay, so let's start. Reasons for FTO assessment. Let's take one step back. During this event, you learned a lot about intellectual property rights, legal requirements, the system of intellectual property rights. Bente last week and Rainer addressed these extensively. But I think it's important to understand a bit the context in which such kind of activity, which is related to intellectual property rights, becomes necessary. You learned that patent is essentially a legal title which grants the holder the exclusive right, not the active right, the exclusive right to prevent others from using the protected invention for commercial purposes without his or her authorization. And you also remember that there's the principle of territoriality. A patent has no effect beyond the territory of the countries for which the patent was granted. So such as, for example, a patent granted for the territory of France has, formally speaking, no effect in Italy or in Brazil. Patents limited for a period of time, up to 20 years as of the application date. At least that's the situation in Europe. Also very important for the freedom to operate assessment. And then there are exceptions and limitations of the patent, the scope of the patent that applies, for example, research on the protected invention. In the context of a freedom to operate assessment, I will come to the definition of this assessment in a second, is first, can I produce and market, so take commercial actions regarding a product or regarding a specific process in a commercial environment in specific countries? That's essentially the definition of freedom to operate. Do I have this freedom to operate for a product or a method to be used in the commercial context? Or, now taking the opposite direction, do these activities fall within the scope of a valid IP right? That's the infringement aspect. They're complementary, it's different angles, but they address the same. What are the activities I'm allowed to take? And correspondingly, if I take actions, what is the risk that I am infringing on third parties' IP rights, and what are the consequences I would have to take? For this purpose, we have to understand what the legal scope of a patent is. You may remember what was discussed already during this event. First of all, the scope of a patent is determined by the patent claims and other aspects of the invention which are not covered, not exactly literally mentioned by the patent claims, are not protected. Yeah? So patent claims are really the pivotal point of patents. And there's a certain aspect I would like to address. Let's take the European patent system, which is defined by the European Patent Convention. The scope of the patent is defined there. So the extent of the protection conferred by European patent and to limited extent by European patent application shall be determined by the claims. Okay, that's exactly what I said. The description and the drawings shall be used to interpret the claims. Okay, it looks a bit like when you read the claim, then you can already define what the scope is. However, there is a little bit more you should need to take into account, and that's the doctrine of equivalence, which means in order to determine the extent of protection conferred by European patent with a set of granted and valid patent claims, due account shall be taken to any element which is equivalent to an element specified in the claims. Yeah, so there's a little bit more than what is defined in the patent claims. Can describe it also in a visual manner. So let's assume this is the set of products that are covered by a specific patent, or the set of different processes that are covered by the patent claims of a patent. And now with the doctrine of equivalence, so elements which work essentially in the same manner to achieve essentially the same effect, make the scope of a patent a little bit broader. And this delta between the scope, including equivalence, and the literal interpretation of the claims can make it very difficult to find all the relevant, potentially infringed IP rights, because it's not easy to phrase it. You need to make, in most of the cases, a manual interpretation of the situation in order to see whether something is not exactly covered by the literal meaning of the patent claims, but with the doctrine of equivalence still covered by this general concept. And you need to be an expert in order to be comprehensive. In most of the cases, I would say literal interpretation can already be enough, at least at early stages of the product development process. But when a lot of investment is at stake, then you need to take this doctrine of equivalence into account, and that's for sure. Yeah, so it really matters. And you should bear it in mind that the scope of a patent is defined by the patent claims, and that there is the doctrine of equivalence. Okay, so this is the background, legal background, scope of a patent. Now, what is a patent assessment? What it is: to find and to assess relevant patents and related IP rights. for example, utility models, but also supplementary protection certificates and even design rights, because of course, possibly it's a product with its outer appearance that is protected by design, which has a scope. And when you bring on the market a product that has the same shape, then of course this design right is also infringed. So when you do the freedom to operate assessment, please do not limit your analysis, your assessment to patents. There are more related technical IP rights, but also design rights, which need to be taken into account. And the coverage of design rights differs from database and service to database and service. So basically, you should understand what you can expect from a service when you do a freedom to operate search. And why is the freedom to operate assessment so important? Put yourself in a position when it turns out later that the product you brought onto the market or the process you use in a commercial environment is infringing other patent rights. The cost can be very significant, not just in the United States, but of course there are some very severe measures against infringement. There will be legal proceedings. You need to have lawyers. It's expensive already. Then there may be possible damages for to be paid for the effect of your infringement, possibly a market withdrawal. Yeah? You would like to commercialize the product, it's already in the repository, but you're not allowed to bring it then to the customer to offer for sale because it's infringing and someone managed to take legal actions against it. And then if you realize, for example, that there's an infringed patent, so basically there is the risk of infringement, you need to redesign the product or process to gain freedom to operate again. It can be very time consuming and very expensive. So it's really good to make this assessment already at an early stage. It doesn't need to be a full scale analysis at all stages. The extent of this assessment will correspond to the risk that is at stake when you don't do it and run into legal and economic problems. So please consider the freedom to operate assessment as a preventive measure to mitigate the risk of infringing others' IP rights and to avoid legal disputes. And with this, basically, freedom to operate assessment, although it may cost money, it shall be part of your risk management. You're willing to protect your property, your IT infrastructure. You take other preventive measures, which also cost money. And this is just another measure, especially in case intellectual assets really play an important role for the businesses. And I think this is carrying calls to Newcastle in this meeting, because I fancy this is one of the reasons why you are interested in the topic. Yeah, so it's very important. Don't neglect it. It may cost money, but it's, I think, an excellent investment. Yeah, there are different stages, different steps that are performed during a freedom to operate assessment. First of all, there's a freedom to operate search to identify a set of patent documents, utility model documents, which where basically the legal scope is defined or claimed, which cover activities you have in mind. Then based on this information, which is usually performed and carried out by a patent information specialist, the so-called freedom to operate analysis is performed. That's usually done by a legal expert, mainly a patent attorney, which will lead to an opinion, what to judge the risk of infringement. And in the end, last but not least, you as the client need to take a decision as to the commercial importance. What is now the conclusion? Do you would like to risk infringement? Do you would like to redesign? We will come to these options at the end, but in the end, it's for you to decide what to do based, however, on educator support by experts. There's a common misunderstanding between novelty and infringement searches. Novelty essentially is something that was mentioned already during the event. An invention is novel if its features are not disclosed together as such in any single prior art. Can be a document, can be a presentation, can be a product, etc. Infringement, basically a physical object. So for example, a machine infringes on a valid patented claim. So specific claim in a patent, sometimes already in the patent application, if the entity shows all the features defined in that claim. Yeah. So here it's the reversal of the order. Similar, when it's an activity, so process you may use, it infringes on a valid patent claim if the activity shows all the features defined in that claim. So the individual steps with the different components which work together. And it has a certain consequence, which I would like to illustrate here using a mock-up example. We all know that there are a lot of complex telephone existing today. Let's assume that you have a competitor who developed a telephone which has two important components, the case and the extensible antenna. And this telephone with these two components is patented. Yeah? This is displayed here in blue. So basically the patent claims of this patent define all the different devices which are protected by the corresponding patent claims. Okay, now let's assume your invention is a telephone which also has a case and an extensible antenna and a self-focusing camera lens, so three components, of which two of them are already known because there was the other telephone by your competitor. Then the question is essentially, can I protect this invention with these three components in view of the telephone that exists already? The answer is yes, because formally speaking, there's no piece of prior art that it discloses all the three components A, B, and C. Yeah, just A and B is disclosed. Second question, can I use my invention or this telephone with the three components? I got a patent. The answer is no, because you would fall with this in the scope of the patent, which defines A and B as an object, and your telephone, which you intend with the three components, also disclose the components A and B. Then there's another question, can your competitor who got a patent for the telephone A and B use your telephone? It's essentially part of the scope of it. The answer is no, because he would infringe your patent. So it looks like a very paradox situation, but there are legal consequences of inventions, selective inventions, which are dependent on another invention regarding what you can protect and what you are allowed to do and not to do. The situation can often be solved by getting licenses, cross licenses, or in case this doesn't work. So you as the owner of the patent on the advanced telephone don't get a patent from your competitor, sorry, a license from your competitor, then in certain situations you have the right to claim compulsory licenses. However, this can be very time consuming and put you at an economic disadvantage and at a competitive disadvantage compared to your competitors. Yeah, so it's a bit complex. So please bear in mind there are different situations regarding novelty of your invention and infringement. And that's also important always. So it's not enough to carry out a novelty search, but also to think from the different perspective, what would I be allowed to do with my invention in case I take commercial activities? Okay, who are the parties involved in the freedom to operate assessment? First, I would like to start with the ideal world. The key players are essentially you. You have an interest in turning your invention into something commercially successful. Then I mentioned already there's someone who needs to perform the search in order to provide the basis for the freedom to operate analysis. The one who usually does the patent search is a patent information specialist, at least at later stages of the product development process, where really a lot of money is at stake, where the doctrine of equivalence may come into play. All these aspects which make the freedom to operate assessment demanding if a high quality of certainty shall be achieved. It's about legal certainty, which has an effect on your business activities, or if it's not done properly, can put you at risk and really put your business concept at risk. Last but not least, of course, the patent attorney, the one who analyzes the results of the search and provides a freedom to operate opinion, and then it's back to you to take a decision what you would like to do. Okay, as I mentioned, that's the ideal world. In many cases, the real world looks a little different. Again, it's you have the interest, you ask a patent attorney, and the patent attorney will do the rest. He will talk to the patent information specialist and order a patent search, freedom to operate patent search, demanding, and depending on the stage, the investment will be higher or lower. In many cases, the patent attorney tries to keep as much money on his side. That means possibly the search that is allowed by the patent information specialist will have a poorer quality than you may need. And second, because you communicate with the patent attorney and he talks to the patent information specialist, a direct exchange is not very common. That can create a problem regarding the scope of the search and what really matters. Yeah, that's often a problem. Please bear that in mind, that you may need situations where you can talk directly to the patent information specialist, either an independent external service provider, or possibly maybe you are lucky enough to have such kind of person already in your company to talk to that person directly. When you talk to the patent attorney and the patent information specialist, it's important to discuss the critical features which should be subject to such kind of freedom to operate assessment. Take the example of a machine. Of course, in order to be absolutely sure, you need to analyze each and everything in the machine. That's not very realistic, at least for most of the situations. We need to discuss and identify the details which are crucial. So those which you really need to put the product on the market, where no circumventing is possible, where it's really a must. These are the details of the product and processes. First of all, in general, what is it? What you would like to do in a commercial context. Second, what are the variations? At which product development stage are you? That will influence the investment you would like to take. When it comes to components in a device, what is the way they work together? The process steps that are important. What is the delta between earlier processes and products and those known on the market anyway? So in many cases, you can limit the freedom to operate assessment to the delta. What is the focus? Shall you limit it to the delta only, or do you need a full-scale assessment of everything because you intend to invest millions of euro? Yeah. Other information is also interesting. The unchanged aspects, can they be assumed to be free to use because they belong to the free state of the art, for example? Should the use of the product be included? So not just the product as such, but specific applications which can justify patent protection as such too. In the following slide, I will just briefly show what you need to do. Formally speaking, when it's about commercializing a product, the whole product should be searched, not realistic in many cases due to financial limitations, but also maybe to the time that is available. What you should also take into account, the process to make the product should be searched, because in Europe at least, the product produced by a process, the immediate product can also be protected, is also protected by default and needs to be taken into account. So process is also very important, although you're interested in the product only. Yeah, process, all the steps should be searched, and often the order of the search step matters, but the order can hardly be searched. So basically, you would search for individual steps and then by manual interaction, try to analyze whether the order corresponds to what you have in mind. Okay, when, yeah, not just once, when you bring the product onto the market. There are many opportunities and many situations where freedom to operate assessment is due in the context of a reasonable risk management in your entity. The reason for this is that the non-conformity costs, so the costs that occur when you don't do it, will increase steeply the more mature your product or process becomes. Here on the right-hand side, you can see a very simplified schematic view of the product development or innovation process. You have the research phase, then development and prototyping with individual sub-steps, then the commercial phase when you bring maybe a zero series product on the market, then you ramp up production, then you have full production, etc. There are, of course, different stages. So take, for example, planning, development, production, sales, and distribution. And these non-conformity costs grow exponentially the more mature the product development process gets. When it's still at the planning stage, and something goes wrong, yeah, I mean, it will be bad, but maybe the financial effect is not very, very huge, or the effect on product development. But the longer it takes, the more money was invested, the more money is at stake, the more investment is at risk, the higher will be the costs. Yeah, and it's in your very own interest to secure these investments and prepare the next steps by taking proper actions regarding the freedom to operate, because an infringed patent can really be detrimental to your commercial activities. Okay, so with this, basically the message is clear. Please consider freedom to operate assessment to a different extent, of course, depending on the stage where you are, but at all stages of the product development process. It helps to early take informed decisions regarding the product development. For example, before starting costly investment, a preliminary assessment may help to take educated investment decisions, to choose different prototype directions, to exclude some of them because they would involve the risk that you infringe other IP rights. Yeah, so even from a technical point of view, they may be better, but for this IP infringement aspect, maybe they are not the one you would like to go, at least not without changes. Yeah, when you do it at an early stage, of course, and the longer the product development takes, you need to update the search again, because possibly some new relevant patent applications or granted patents will pop up. There may be international applications with a very generic scope of the patent claims, which turned into something specific, which, however, then really cover your intended activities as well. And then, of course, before the product launch, when the list of features is decided, and before the product is brought to the market. You may remember legal disputes in the area of mobile phones, Samsung versus Apple, and the detrimental effect of infringement was very clear. It stopped the parties partly to bring their products to the market shortly before Christmas. And of course, this is from a financial point of view, far from what you intend as a company. Yeah, where I mentioned already that geographical coverage is important. You remember the principle of territoriality of patents and other IP rights. Here, it's very important to remember what you would like to do. Where will the product be manufactured or the process be applied? Here you need to have freedom to operate, otherwise IP right owners can stop you from manufacturing or from compiling products or using technical processes. Second, important is everything important for your intended activities produced and processed in the same countries. Is there a cross-border activity? You need to bring certain components to other countries where something is then compiled. So these countries need to be taken into account as well. And then where is the product going to be sold or used? This is your market. And also there you need to have freedom to operate. Okay, that brings us already to the freedom to operate search. I mentioned already that you find more information in the set of slides you will receive, but for time reasons, we can only present a general overview here. You remember the 4 steps of the assessment: the search, the analysis, the opinion, and the decision of the client. So different parties are involved. And I would like to say a few words about the freedom to operate search. It's basically a 5-step procedure. First of all, the patent information specialist or the party doing the search need to understand the needs of the client. And if the client is the patent attorney of the customer behind, that's you. So basically what is important is really an exchange of the key features of the product or process that need for which the assessment needs to be done. It's not enough to send a patent claim. You really need to define the product and service, the process and the key features, so those which are really crucial and a must. Then a proper search approach will be done. A preliminary search will be carried out, exchanged with the client or the customer behind it. Once it's accepted, then based on the search objective and the methodology chosen, the search will be performed. Potentially relevant documents will be selected based on what is claimed in the patent claims, but also what may be claimed, so is already available in the description, but not currently claimed. And of course, the doctrine of equivalence will be important. And of course, also the so-called legal status is important. So in any information on the procedural status of either the patent application, which may lead to a valid patent, and may also have legal effects with provisional protection already after publication. And of course, whether the patent is still in force or may likely be in force at the moment when you take the commercial actions. Yeah, and then this is compiled and reported to the client, so the legal expert who then takes over and does the analysis to spot relevant documents based on the information, and then to provide an opinion regarding the risk of infringement, or in other words, the freedom to operate. Okay, for this, certain questions need to be addressed. First of all, I mentioned already, what is the product or method to be assessed? What are the critical essential elements? Because in most of the cases, you can't do everything when it's a machine. You can't do each component, each coating, each screw, and do a freedom to operate assessment for it. Identify those critical aspects which are really a must for your business strategy. This will define the subject matter and the extent of the patent search. And then basically the methodology is developed based on patent classification codes, keyword concepts, analysis for specific applicants, which are your competitors. The geographical scope plays an important role. And all this is done by using appropriate search tools and databases, which need to be sufficiently complete and accurate regarding the territories you are interested in. And it's really something I would like to stress. For example, if you would like to make the freedom to operate analysis in Latin America or Asia, please be sure that the databases and the search tools, the patent information specialist or you as an alternative would cover these territories to the degree necessary, including patent documents, but also the procedural information necessary to judge then the legal status of the applications in question or the patents. Yeah, then based on the search, complementary search, so I think combi searches, the documents are categorized and characterized, and then the results will be reported in a document with the search objective as agreed with the client and customer, the search methodology, the database is used, its limitations, the list of potentially relevant patent documents, which with a reference to the critical patent claims, so those of which the scope may be infringed, and related details in the description supporting the message on the patent claims, but also parts, for example, embodiments in the description, which are not claimed in the version you could see as the specialist, but which may be claimed during the application and granting process. Yeah, and then last but not least, sufficient information on the legal status and also patent family information. Related patent documents and other legislations which may possibly also be important. Yeah, also is collected free state of the art, which can be very helpful when you need to question the validity of IP rights, which are found to be valid in order to make the way free of these documents. Yeah, so also other information is collected and provided in the document. Here, very important again, communication matters. And in order to be successful and to satisfy the need of the clients, clear and open communication is a must. Yeah, I mentioned already that the tools and databases have to meet certain requirements. What is important is that the databases have a good or excellent coverage of prior art and procedural information for the countries for which you need to assess the freedom to operate. I mentioned already the example of Latin America and certain Asian countries, but also countries in Europe are covered to different degrees. It's always advisable to go to the authoritative national interfaces, but for search efficiency, you usually use centralized database and centralized services which allow you to search for different authorities. Yeah, full text data is also important to access the information in the patent claims, but also in the description where important embodiments may also be disclosed, which possibly may be claimed during the application and granting procedure. Powerful search interfaces are important. And I mentioned already these searches and the assessment should be taken at all stages of the innovation process. Yeah, and it's a continuous activity. You have to monitor the validity of applications and granted IP rights which were identified as relevant to see whether they still are valid, whether they may have resulted in a granted patent, for example, when it comes to applications. So it's a continuous activity and not a one-off exercise. Just to illustrate a bit the principle here, you can see information on the coverage of abstract information for patent applications and related documents in the EPO's worldwide patent data, which is usually the source of most commercial services in the area of freedom to operate searches. On the horizontal axis is the application filing year. You need to assume to search in the last 20+1 year. So basically, when we have 2025, at least 2004, plus more time is needed, for example, in the area of pharmacy and plant chemistry, where also supplementary protection certificates and related supplementary protection rights are available. Green means that for each application in the patent database, there's also abstract information. So these documents would be identified if you search for keywords in the abstract. For many of those, you may miss these documents if you relied on abstract information only, because either they're complete gaps or the coverage is clearly less than 100%. So depending on the authority, data coverage may be good, excellent, complete. This doesn't answer the question whether it's now complete regarding the amount of patent documents. The EPO and other service providers do their best to increase coverage, but still it's not perfect. And you have to know the extent to which it's not perfect. There's a large number of, in my view, powerful free of charge search interfaces. I just list some of them here. Important, for example, as far as the European Patent Office is concerned, is ESPASnet. It's a free of charge service, which allows you to access information on more than 100 million patent documents, of more than 150 million patent documents from more than 100 patent authorities. So a lot. Other services offer also mainly for their own territory very comprehensive information. And sometimes you would like to choose the one service, sometimes the other, depending on the geographical scope and the purpose of your search. Then there are added value services, which usually rely on the EPO's worldwide patent data I mentioned already, and put more data in it, also add added value information, which allow you to be more efficient and more comprehensive. And depending on the purpose of your analysis, you may start, for example, with free services, but then if more money is at stake, of course, should consider to use commercial services, because the coverage they can offer is higher than what you usually can expect from free services. Yeah, I mentioned already ESPASnet. Here's just very general information, quite comprehensive and quite useful for at least for the early stages of your product development to get an idea. Please don't forget, the more money at stake, the higher are the requirements regarding the quality of the assessment. Yeah, There are other sources of information which we can recommend to consider. Information on competitors, other companies that are in the same technical field. The EPO offers the Deep Tech Finder. It's basically an interface that allows you to access information to more than 10,000 entities. Since recently, there's also an app available, so you can use it on your mobile phone. You can find information on universities active in many technical fields, investor information, startup information, and much more. So this service, for example, offers you information that is related. It cannot replace a freedom to operate assessment, but can complement it and may be very useful at certain stages and to answer specific questions. Yeah, once you completed the FTO assessment, and in case, for example, you identified a set of patents and patent applications which may be potentially infringed, it's not that basically it stops your business. There are certain options you can take into account in order to solve the problem and the challenge imposed now by the risk of infringement. First of all, I mentioned this option. You may try to design around what is protected. That clearly helps to avoid infringement. It may be a cheap option, but in many other cases, it requires substantial R&D investment. It costs money, it costs time. You need the experts to do that. So that may delay your activities. And although it looked cheap, it may be rather a showstopper because it put you at a competitive disadvantage. Then a second option I would like to mention, challenge the validity of the infringing IP rights. The fact that there is an IP right doesn't mean that it's valid. If the application granting procedure was good, I mean, for example, let's take the European patent application and granting procedure, which gives high quality patents, that the likelihood is very high that the patent is valid. But there may be situations where some information relevant for the novelty escaped the attention of the examiners because, for example, it was a remote source or something that is not well documented. You can take actions in order to provide this kind of information to question the validity of a patent and to have either the IP right invalidated or their scope limited to the extent that what you intend is no longer covered by the IP right. So basically, you reshape the scope of the patent by having these invalidity proceedings, and preferably when you do the freedom to operate assessment, mainly in the freedom to operate search step, you may collect prior art that is already state of the art, a free state of the art, and can question the novelty of an existing IP right where you possibly have the risk of infringement. Yeah, so it's some kind of side effect, but a very important one of the freedom to operate assessment, to have enough ammunition to question the validity of potentially infringed IP rights. Then license, of course, try to get the right to use the protected technology. That usually may create costs, but it gives legal certainty. So I think it's a very convenient option. We discussed it already last week. Or buy the IP rights that allows you to get direct control of the infringed IP rights, to monitor the infringed IP rights, for example, to track the potential lapse of an IP right, the expiry, or the invalidation, for example, by others. Yeah, that helps to avoid unnecessary actions, but it may take time, and that again may put you at a competitive disadvantage. And also it depends on the IP strategy based on the business strategy of the IPR owners, which you cannot influence much. Yeah, so there are different scenarios. There are more scenarios which you have, but I wanted to list important and major ones. And you can choose depending on your strategy, your financial capabilities, and your willingness to take risks. That brings me to the end of my presentation. I just would like to briefly sum up. First of all, what is freedom to operate assessment? Please remember that it's to find and assess relevant patents and related IP rights that form a risk in the countries targeted for the manufacture of your products, for the sale, for use, so for basically for your commercial activities. FTO assessment costs money, similar to other activities which cost even more money. It's a preventive measure to mitigate the risk of infringing other IP rights and to avoid legal disputes. It's part of your everyday risk management, and I think it's an excellent investment. The freedom to operate assessment has different steps: freedom to operate search, the analysis, the opinion, and finally the decision of the client. That's essentially you. There are three parties involved: the patent information specialist, the legal aspect, and basically you as the client, and all have to contribute to make it successful and to have it performed in an efficient and effective manner. Yeah, in case there is the risk of infringement, you have different options, what you can do, ranging from redesigning products and services to questioning the validity of the potentially infringed IP rights, to getting licenses or to buy it. Yeah, that brings me to the end. I hope you found this presentation helpful. Again, it's just an overview. We provide more information in the set of slides. And as it is a very demanding and comprehensive topic, being familiar with it will take time, but you don't need to familiarize to a high level of extent yourself, because there are experts available that can support you. Many thanks.
Thank you very much, Christian, for this very concise overview, which is a starting point, as you mentioned, of course. Coming back to, we received a couple of questions. We already answered some of them, but I'd like to bring some of them also back. And concerning, you mentioned the IP expert, I found that one quite interesting, also quite practical. We had someone asking, and I think also Thomas joined in answering, is it better, to use the same IP attorney that writes your patent claims to also do the FTO, or would you recommend a pair of fresh eyes? Is there any experience from your point of view to look at and do an FTO, for instance, to have it separate, or is it good to have it all in one hand?
It depends a bit on the profile of the patent attorney. So if he or she only specializes in drafting applications to get a patent for it, then possibly I would advise to look into someone who really specializes in this demanding activity and also is familiar with enforcing invalidation of IP rights. In many cases, at least that's my personal experience, there are experts who offer IP strategy, where patent applications are part of it, but only as part of the IP strategy. And this freedom to operate is part of their activity. So they offer a portfolio where it's a genuine part of it. And I think these are experts who can offer the service. It's not against other patent attorneys, but I would look into someone who has more the business, so the IP strategy aspect and perspective, than looking someone who is highly qualified from a technical point of view and can draft excellent applications, but without any other activities in the portfolio.
Yeah, that makes sense. I was also wondering, another question, if we talk, especially if we talk about deep tech solutions, if we heard throughout the training, we also hear that these kind of inventions or new solutions often depend on third-party components. So how does that affect my FTO? I mean, the one thing is what I develop myself, but how do I handle, potential third-party components which are part of my novel solution, and how is that affecting FTO assessment?
I mean, formally speaking, when you buy something from a third party, any rights of that party on the piece is exhausted. So any patent rights are exhausted. However, it does not answer the question whether the component as such is infringing on third-party rights. And formally speaking, if it's a critical component, you need to make sure by active confirmation of the service provider, for example, by having performed a freedom to operate assessment himself or herself, that the component can be commercialized. Otherwise, it doesn't help you much. Then you bought it from that service provider, but it's still infringing third-party rights. And then basically this IP owner can close your shop or prevent you from commercializing it? So it's really an important question. So there is this principle of exhaustion regarding IP rights of someone who sells the product, where protected technology is, but it does not solve the question or answer the question whether he has the right to do so. And that's something that needs to be cleared. And the higher is the risk at stake, the more they should spend time on making sure that there are no infringed rights regarding this component.
All right.
If you can exchange it easily, possibly there is no big risk. But if it's really something you cannot exchange, it will destroy your own business strategy as well.
Yeah. Yeah, you mentioned that, and I also saw that in a couple of questions. So as you mentioned, FTO is an ongoing process. So what happens if at some point all of a sudden, hopefully not, but maybe you've missed something and there is a patent coming up and you have to then find a workaround. What are strategies to do that? I saw Thomas also partly answering that with regard to, defensive publications. Maybe we can comment on that, or Thomas may join us here and as well. So, I can imagine that these are things that people wonder about. So I do that. It takes time. It's a lengthy process. So what, at some point in this process, something comes up which poses a risk, and how can I handle that?
Maybe that's something Thomas can say, but I think at least it's in your hands to minimize this risk by due diligence. And due diligence here means really to assess the risk early on, depending on the stage where you are. And then there may be situations where possibly something when the analysis and the assessment is done carefully, something pops up. And then you need to be practical. But I think Thomas has now a say here because you know better what is typically done in these situations, I fancy.
You're still muted, Thomas.
First of all, it's like you said, Christian, you want to be proactive and have done the proper risk management. And actually also the defensive publication is one of the means to make sure that there is, let's call it burnt ground for others to jump on something that you have already developed, but where you have finally concluded that you would not go for patent protection yourself. And of course, you would not disclose in everything. You would disclose what is relevant for the others in respect to inventive step and novelty, and also enough that they cannot get strong patent protection, so that you still keep the freedom to operate for that part that potentially can be patent protected. So that is, of course, one aspect. And the other aspect is if something pops up, then this proactive tendency should stay because it's not good to ignore problems. And there are many strategies to do that. I had, before I joined EPO, I had a client who had a problem with freedom to operate and has signed a marvelous contract with one of the main sellers of cell phones, where everything was in the contract that made sure that they have all the liabilities. Imagine that you have delivered a part for a cell phone that is sold worldwide and it's taken out of the shelves of the shops. That would cost an enormous amount, and you have the liability for that. And this situation was there for the company. And what they did is to create a patent pool for cross-licensing, to have an active strategy. Look, who are the owners of the patents that they infringe? Can we negotiate them? It was a small company. They even thought about buying the company. There are so many means that you can address when you think strategically and proactively, not just wait till worst case happens, but that you have a plan. So and a positive attitude towards it, to solve it and to find a win-win solution. Because at the end of the day, the economics will not change. At the end of the day, a product is sold. And for the product, you always can have a certain amount of royalties, and that has to be shared between those that contribute. And there you need to find the right spot, and everyone who contributed should earn his fair share. And that has to be negotiated and found out.
Yeah, thanks very much for reinforcing that message, Thomas. I know Christian is a busy man and has to leave us right now, but thank you very much for joining us and for sharing your insights.
Thank you very much. It was a great honor for me. Many thanks.
Hope to see you on another training occasion again. And maybe another point that was raised, not so much a question. So before we come to the final part of this training, we heard about using this, as a platform to connect and build relationships. And I know that Thomas wanted to comment on that as well, probably inviting people also to join us on LinkedIn and community to stay connected.
Yeah, absolutely. So it makes perfect sense to connect. And in the age of data protection, it's more difficult to have running lists of contacts that you invite for events. And therefore, we are very grateful if people stay connected with us. And there are several means. There is an Academy newsletter and these things that the EPO and the EPO Patent Academy offers. But there are also cooperation partners of us, like LASI, that have an HDB community page on LinkedIn, where people can become followers. And when we have new events, new material or whatever, then we are happy to share it there. Together with our partners, of course, the IP Help Desk, it's not only about LASI, it's about all those that collaborate with us in this joint effort to make life easier for the innovators and to provide the missing information that you have not ready at hand by quickly Googling, but where it is worth spending an extra effort to make information available.
Yes, thanks so much. And also thanks to the participant raising that point. Connecting is also a good word to jump on to smoothly transition into the last part of that training. Christian actually rounded off the content part, and now Thomas and Adéla, who I'm inviting to the stage again, will help us to connect the dots a little bit between the two sessions that we've had, and to highlight once more how IP strategy and management actually go hand in hand together. Adéla for Dvořáková, for those who join us for the first time in this session, is a project advisor, very experienced in supporting high-tech companies in matters related to IP management and IT strategy. And together with Thomas, she's been one of the driving forces behind this training. So welcome once again. And please, the floor is yours.
Thanks a lot, Stephanie. So from my side, it will be quite brief. I would just like to say that I'm very happy that we could have this training together with the EPO. I'm absolutely sure that all the EIC beneficiaries who joined us could learn a lot of useful information from this training. It was very practical, very hands-on. But I would still like to ask Thomas a question, because I think that it would be a good way how to end this training to kind of put it all into perspective. So Thomas, last week we heard a lot about IP strategy, which is kind of like a long-term plan that a company should have. And this week we heard about IP management. So let's say how you go about implementing the IP strategy. You, in your presentation, you presented to us a kind of structure, how you go from creation through assessment, protection, and so on, which sounds like, let's say, a linear process. And I would like to ask you, is that really so? Wasn't that a little bit of a simplification, let's say? Would you like to comment on that and put that all a little bit into, to give a broader picture to the audience?
Yeah, so you are absolutely right. When using the tactical means, you always need to simplify things so that you can convey the concepts. I think we made acceptable compromises. In particular, when it was about IP strategy, we stressed a lot that IP strategy is not a copy-paste thing and so on. So I think here we did actually the opposite. We made clear that this is a challenging aspect, something that needs dedication, that needs training, that needs expertise. And the intention is that it's taken seriously. And that it's done in the way that it is effective. because you, at the end of the day, what counts is that you achieve your business goals that you have defined beforehand. So I think that that is the aspect there. In respect to IP management, I followed a different approach. You got me. I oversimplified a little bit, but I already mentioned that without having the complete picture, you are on the wrong track. I remember well when I started the technology licensing office at the Technical University in Graz. I made a roadshow to see and learn from the others. And in Stanford, I saw how they do it, and I saw how the German colleagues were doing it that had just a few years more of experience. And they only focused on the first step. They focused on creating IP and filing as many patents as possible. When I asked them, and what are you going to do with all those patents that that you have filed at the German universities? What is then the plan? That we will see. We will then see. And then they have not done the selection. What I brought up as being part of that you need to make informed decision and select those candidates, those technologies where it's feasible that you can commercialize. And they had then huge problems with their inventors because they have invested a lot of time. And many of those 5 patents never made it to commercialization. And that meant they had a lot of frustrated inventors that have spent weekends and nights to write dimension disclosures, file the patents, and all this effort was invested for nothing. And that is an example where one part was left aside. And what I would like to emphasize is that you have a vision for all the steps that come. Without knowing the details, it should not be a hurdle that you have. It should only be the foresight that you need, that you know that there will be a selection process. There will be the protection process. And the protection process, you will learn a lot when you see what the examiners have found for your technology. When you get the search report, when you discuss with the examiners, you will learn a lot. And this learning has then to be translated into your actions where you say, okay, here I get a strong pattern, that's worth the effort. Here I have a weak thing. If I would spend a lot of money for lawyers and litigation, I might make something out of it. But is that really my business case? Is that really my vision that I have? When I'm smart enough to have strong technologies, strong patents, then I will go for that, where it's straightforward. And therefore, you want to have an outlook. Of course, you will not have the crystal ball, but you want to have an outlook. What are the next steps ahead? Yeah, and if you do that also then in the other direction, because we in the program we said closing a loop, so to connect the dots. Yeah. I would like to come back to the tool that Johannes mentioned, IP Score, because for other reasons, I was actually forced to use IP Score heavily also for reporting, because when I had the technology licensing office, my rectorate said, okay, Thomas, you are the volunteer for getting ISO certification because you are the only one who works with processes, and so you are the dummy that has now to show the external advisors that we work in a structured way. And I thought, okay, causes me a lot of effort, a lot of time that I don't have. I will make something useful out of that. And what I did is I analyzed the last 50 cases where we filed invention, where we filed patents and where we commercialized. And I looked into the history of all my files. Where have we successful? Where have we not been successful? What were the drivers for the successes? What were the drivers for the failures? And what have been our assumptions before? Because in IP Score, we had all those 40 questions, and we documented that, and we documented what we thought at that time. And then later on, when you look back, then you can see where you have been right and where you have been wrong. In which cases, for example, our state-of-the-art search was not good enough. Where were the freedom to operate search? Not good enough. So then you go back and you learn from every mistake that it doesn't happen a second time. And with these kind of iterations that are then actually triggered by IP management, you come back to the strategy, because what you have learned on the IP management level must influence your future decisions about what you want to achieve in which way. And then you have a perfect full loop. Then you have a continuous improvement system that shows yourself what are the criteria for success and failures, but also to explain others, because I stressed this is a team sport, and in a team sport, everyone wants to understand what are the criteria for success and what everyone has to avoid. So that needs to be a shared information. No football team would do analysis in secrecy and not share it with the colleagues to learn from it. The whole team needs to know it. And that is something that I learned in that context in a very nice way. And that is something I would like to give anyone on his way, even if you are early in your career, early with your startup, start thinking like that already now, because that will sharpen your view on the things. And with every success and with every failure, and sometimes with the failures even more, you learn what drives the success and what to do in order to succeed in the innovation arena.
Thank you, Thomas. I think that's a great way how to wrap it up. I would maybe rephrase it in a simple way. I would say you should start with IP early as possible, and IP is an iterative process always, right? It's not like that you create your IP strategy and then you implement. You always have to be revalidating the strategy and developing it and checking if you actually made right decisions in the process. So I think that this is a good, let's say, takeaway with which we can end this training. So from my side, I would like to thank all the speakers for their great presentations. I think it was really insightful and great. Thanks for all your great work. Thanks to you, Thomas, as well. And thanks to Stephanie as well for the great moderation. And so on behalf of the EIC, I thank all of you and I say goodbye to you.
Thank you so much. Yeah, I think I have nothing to add. I was just wondering, Adéla, since we have you here now, I just saw that a last question, and maybe this is still, because we still have the time, we're ahead of time, and it's related to the EIC and the freedom to operate search analysis, so everything that we heard about, and how important that is for an EIC transition application, for instance. Maybe as we still have you here on spot, that might be useful for the beneficiaries to know.
So if you ask specifically about EIC transition, so for the application, it's actually not necessary to submit an FTO analysis, but it's of course advisable. It's advisable that you have already done it before, and it's definitely highly recommendable that you do a proper, fully fledged FTO analysis during your transition project. That for sure. But I would actually personally recommend you to do it much earlier, already in your Pathfinder project. I think you should be checking if you have FTO, and in my view, it's never too early to start checking your rights and your prospects for commercialization, even if you are quite early in the process.
Yeah, thank you. I think it strengthens what you've just said right before the question came up, to think about IP as early as possible. Yes, Thomas, do you want to add to that?
So I was involved in the IP management of a research organization focusing on industrial biotechnology, having many pharmaceutical companies on board. And there it was also one of the main criteria in the research projects as such, because you always have, like I brought up my statistics, so this example, of course, in pharma and biotech, it will look different. The numbers will look different, but the principle is the same. And when you have many optional approaches, then we had in parallel to the state-of-the-art search always a freedom to operate check, because in biotech, nobody wants to run into big issues in that respect. And so a preliminary FTO search was at every stage of the research projects where analysis was done. It was an integral part. And it was good, and it was not substituting a top-notch FTO search that the pharmaceutical companies reserved for themselves. They always said, this is all what you can do is only preliminary, because only we, with the top specialists and so on, we will do the nitty-gritty details and then finally decide. But we want to be sure that we don't waste research resources and years of research for something that is a one-end road where we're only stepping on the feet of others, and that doesn't make sense. Yeah.
Thank you very much. And so, yeah, I'm sorry for squeezing that in, but I think that was yet very important and an important message to bring across to people. So with that, also from my end, thank you very much. Lots of perspectives and insights. And as we all mentioned, hopefully for you listening to us and being part of these 2 sessions, you got some, inspiring things to think, well, lots of food for thought, I think, and to look into in more detail. As you know, there are different training opportunities all around to potentially dive deeper into the individual topics that we touched upon. And as Thomas mentioned beforehand, we'd love to connect via the HTB initiative sites and the other channels that we have to really shape this vibrant community that we have, learn from each other, learn from failure, as was mentioned, and just try to shape, the future that we're living in, essentially. So thank you very much for joining. And hope to see you soon on another occasion, in another training. Thank you so much.
Thank you.
Thank you.
Thank you. Bye-bye.
Goodbye.
Bye.